Hello everyone. So in this particular video we will be implementing a real world dataset problem, that is breast cancer classification using logistic regression in PyTorch. The aim of the particular video is to help you get started with real world datasets so that you can move along and implement your own linear logistic regressions, and will also help you in the future videos. Okay, so before I get started, I would ask you to go and follow me on Instagram, or if you want a one-to-one kind of a video consultation on your project or just anything related to computer science, you can definitely check my Fiverr page. It's really cheap, it's just $5. Okay, so first thing is that we need to get the dataset. So I already have written the code to get dataset from Kaggle. It's one place where you can get datasets for free, so I'll not be discussing it right now. I'll be making another video probably, and then I'll show you how to get datasets from Kaggle. Right now I'm just copy pasting and running it. Okay, so this was there, and our dataset is the breast cancer dataset, as I told. So the first thing after that, after the dataset, that what we need to do is to actually unzip it. So okay, rather before even unzipping it, we will import the basic libraries. So we will say import torch and import torch.nn as nn. I think even numpy will be required, so okay, import numpy as np. So we will be importing other libraries as we go along. Okay, so now we will unzip whatever we have downloaded. So if I can show you right here, so yeah, breast cancer Wisconsin data.zip, and then we get data.csv. So then we are going to read the CSV file. We will be importing pandas for that, so import pandas as pd. So we will say data equal to pd dot read csv, and then we will be giving the path of the CSV file. So you can go here and say copy path and paste it over here and shift enter. So now what we can do is we can actually see the data frame. First let me close it. So data.head, if you want, tell me, I'll make a pandas video for you, or even a series which will give you at least the basics of pandas. So as you can see, we have 5 rows because we did a head operation, and 33 columns. This is the important part. And I have checked the dataset. There is only this diagnosis column, which is our target, which has string labels. Okay, rest others have numerical values. You can also, what you can do is you can drop some columns here. First I'll drop the ID column here. Okay, or before that you can do the most basic thing, is that to find nulls. So we'll say data dot is null. So null is basically if you have a nan kind of a value, dot sum. So what this is going to do is actually go and see for each column if how many nulls or nans we have. So most of it is 0. This last one, unnamed 32, has 569 nans. So if I just scroll it over here, I think it will have, yeah, it will have nans. Okay, so looking at the shape, let's look at the shape first. So we know the last column has nans. So if you look at the data.shape, some 592 nans were there. Oh, sorry, not 5, some 500 something were there, and 569. Oh, I think all of them were nans. Okay, fine. So let's do something. Let's just drop. So for that, we need to know the names of the columns. So when you say data.columns, you get all the columns that are in this particular data frame. So you see last one. Okay, so we'll say -1. This will give us the last one. Now in order to drop one column, what we need to do is we need to say data.drop, and then put this in brackets, and then we have to specify the axis. So if you want to drop a column, you have to say axis equal to 1, and then you have to do in place equal to true. Otherwise what this will do is it will not make changes in the real data frame. It will just show you one corrected data frame, but the column will stay. So for that you have to write in place equal to true. Another column that I want to delete is the ID column, because we are not going to use it. So these two columns, the last one unnamed 32 and ID column, will be dropped. So if you run this cell and then do data.head, what you are going to see is that we will have 31 columns, right? Because ID column and the last unnamed column has been deleted. Now we will remove the diagnosis also. Yeah, we can do it right now only. So what we will say is, we will say data bracket and then we will say diagnosis. So let's print it. So you can see these are all the values, okay? I think this is M stands for malignant and B stands for benign. I think that is the case. So this is our target, so we will say TAR target. Now what we need to do is drop this also from the data frame, because we already have it here. So data dot drop, and then you can say diagnosis, and then again x is equal to 1 because we are dropping a column, and in place equal to true. So if you do this, we will get our target. So let's just print the target once for us. Yes, or target dot values, then you will get it in a list kind of a format, array format, whatever. So that is there. Now we have dropped the diagnosis, and now what we need to do is to do a train test split, because we already have the target and we also have the data which is now cleaned. So what we can do is, in order to do train test classification, train test split, we need to do from sklearn dot model selection, and instead of a dot I put a slash, model selection. From this we need to import train underscore test underscore split. Okay, so it came and run. Now what we will do is, we will say train x test x. So this is going to be our train data frame, and we can call this as val or test, but we are using train test split. We can say test. However, what we are going to use it as is validation, so we will just leave it that way, and then train underscore y and test underscore y. Okay, so we will say train test split. Now what we are going to do, we will say data, because this is the data frame, then we will say target, because this is the target column, and what we are going to do is, we are going to pass the test size. We are going to keep it really small because we don't have a lot of data points, so we will say 0.1, that is 10%, and random state, it is required if you want to reproduce the same splitting. So we will click enter, shift enter. So once we have done that, let's see the shapes. So train x dot shape and test of x dot shape. So if you do that, you will see that okay, 512 data points have come in the train data frame, and 57 have gone to the test data frame. So that will be same for the targets also. However, what we are going to do right now is going to change. Now if you remember, when we print target, we will print target once more, we see that this is in the format M, and then there's one B also. So these are strings. Okay, so we cannot have strings in PyTorch, because we need numbers to do computation. So the best way to change is using something like this. So we say np numpy np.where, and we will say train underscore y, because that was the train target values, equal to, let's say, m. So whenever the train value, which is this, equal to m, substitute it to 0, and if it is not the case, that is when this value is b, say it's 0. Okay, so whenever the train y is m, 1 will be substituted, and whenever it is not m, 0 will be substituted. So for 0 you will have 1, for 1 we will have 1, for 2 we will have 1, but for 568 we will have 0. So for all the okay, so what has happened is I have not reset the index, that's why you are seeing here 512 and here 568. Okay, I just made it clear. So this will be for train underscore y, and the same thing will be done for test. So we will say test underscore y, and here we will say test, and then we will run it. Okay, so we will say values and not value. So I think it should run, yes. So keep in mind this is values and not value. It happens. So once we are done with this, now what we are going to do is, if you remember, like I have done this before, if you remember from here, see these values 17.99 or 18, 20, and then you have some values that are 0.277, 0.07. So you see the scales are not matching, and the best way to find this is you can do data.describe, describe. Okay, so when you do that, you can get information about all the columns. So you see count will be same because all of them were the same, these many data points were there. You see the mean, here it is 14, here it is 19, here it is 91. So here also the scale is not matching, and then here the mean is 0.096, which is too small, and this goes on for the entire data set. Okay, so what we need to do is we need to get these values on one scale, that is ideally 0 to 1. Now why do we do this? It's because it makes the neural network train, or logistic regression network train easily. Otherwise you'll have to take into that, the network has to take all of these things into account, and the loss function will have some problem. Okay, you'll have unrealistic losses if the values are just too big. So what do we do is we use something from the sklearn package. So we go back and import from sklearn dot, now this time we are going to import from pre-processing. So sklearn.preprocessing, from sklearn.preprocessing import standard scalar. Okay, so capital standard scalar, and then we will hit shift enter. So what this standard scalar does is it brings all the values, all the columns into a one specific, inside one specific range. So ideally 0 to 1. So the way we instantiate is we'll say SCA, and then we'll call standard scalar. Okay, open close bracket. So we will instantiate this. Now we need to first fit this, or rather train it. So we will say SCA.fit, and what we are fitting on? We are fitting on the data. Now remember, data is the whole of the data frame, right? From there only we took out train x and test x. So train x plus test x is going to give us the whole of data. Fine. And this is important. Do not do it on just train y or train x or test x. Otherwise you will have some problems because the data set needs, the range needs to match. Okay. So once we are done with that, we have, I think, fitted this. Okay. Now what we need to do is we need to use train x dot sca dot transform. So this is how you are going to transform the data, and same thing for the test. So we will say test underscore x sca dot transform test underscore x, and then we will hit shift enter. Now if you see, let me just show it to you. Oh, sorry, not shape, we'll do head. We already know that 512 is the shape. So when you say, okay, now I know what's wrong, train underscore x, just print train underscore x. You see all the values are between like very small range, they are not very big or very small. Okay, so I think you can also do it like this, maybe, but the column may be missing. I'm just trying to see if this helps to get a better view. Okay, so if you do this, so what is happening, you can see the range is still okay now, like it's 0.9, minus 0.9, minus 1.6. Otherwise before we were having values that were too big. Fine. So now you are seeing the values have come into a particular range. Now what we need to do is, now we need to start the PyTorch stuff. So what we need to do is we need to convert all of these things into PyTorch tensors. So we have been doing this in the last two videos in linear regression, logistic regression, and the same thing we are going to do it right now. So what we will say is, let's say train x equal to torch.tensor, and then we will pass train x only. Fine. And just to make it into float, we will say dot float, open close bracket, and same thing we'll do for test x, test x, test x, and same thing we'll do for train also, train y and test y, and finally we'll do test y. So now this is ready. From NumPy we have come to PyTorch tensors. Okay, test y karna tha na. Fine. Train x, test x, whatever. It is recommended to use so delete as requires grad rather than torch.tensor. I think our work is done. Train underscore x. So if you print the shape, so you can see it, tensor was there and 5. Okay, fine. Which means our work is done. Whatever the warning was there, you don't have to care about that so much. Now what we need to do is, now that we have got our tensors, our data frame as a tensor, our target also as a tensor, now what we need to do is we need to define the model. So we'll say LR, like in the logistic regression time, module. If you remember, you can type along with me, and guys, please type and try this program by yourself. It's going to help you in really grasping the concept to the core. Self, I'm going to pass number of features because it can depend on the data set that you use, and then we'll say layer 1 equal to nn.linear and n features comma 1, because we are having logistic regression, so we'll have only one output neuron. Then we need to define the sigmoid layer and pass in no parameters. Def forward, so we'll write the forward function self comma x. Then we say out of 0 is self dot layer of 1. All this was already shown in the last logistic regression video, so I'm really going fast. So the sig, and then we will give output of 0, and then we will return output of out of 1. Okay, so this is going to be our model. Hopefully this runs fast, and then we'll say model equal to capital LR, and we will pass 30 as n features. Okay, so these are the number of features. Why 30? Because if you remember, there were 30 columns. Fine. So, or rather in the data also there were, okay, we had removed the diagnosis, so 30 minus 1 is 30. So 30 columns. So now what we will do is we will run this particular cell to a given. Okay, the one thing that I had forgotten is, I always forget this super. Okay, so what you do is, I think I've given an extra here. Yeah, lr dot self init. I think now it should run. Yeah, so I gave an extra underscore over here and I forgot the super. So if you forget this, obviously you'll get an error later. You'll not get error out here, you'll get error in the training loop. Fine. So after having done this, we'll define the loss. So loss function, again, this is also something that I have already shared with you last time. Loss, and then then we'll say optimizer is equals to torch dot optim dot stochastic gradient descent, and then we will have model dot parameters, and then we'll have learning rate equal to 0.001. We'll just keep it low. So LR does not have to parameters. Fine. Now we need to do the last thing, that is to write the training loop. So we'll say number of epochs equal to, let's say 100, then for epoch in range number of epochs. Again, all of these things were already taught in the logistic regression video, so if you haven't seen, please go back and see that video. Now what we need to do is we need to say model and then we need to okay, we can do this way also, model, and then we will pass in the train underscore x. Okay, and then whatever will be the output, we'll just call it output. Fine. And then we will say we'll first have train loss. So today I'm going to show you one more thing, what is how to get the train loss and test loss. We have been getting train loss like in the linear regression also and logistic regression also, but you can also get the test loss, or in this case we will say validation loss. So we are not testing anything, we are actually validating, but you can use that interchangeably, at least for now. Train loss dot append. So loss will be actually loss. First you have to define the loss. Loss is loss function, and then whatever output you got. If you remember, we had to use squeeze. I told you about how it works, and then you'll get target and train underscore y. Okay, and then what you did is loss dot detach dot numpy. This is what we did. Okay, so after that what we will do is we will write the three sentences that I told is very common in almost all of the PyTorch programs. So it says 0 grad, then we will have loss dot backward, and then optimizer dot step. So these were the three lines that are. Now another thing that I wanted to show you here is what we need to do is, in order to find out the test loss, first let me say test loss, or you can also say validation loss. In this case we will first have to say with torch dot no grad. Now in the next or next to next video we will be doing PyTorch tensors, and after that I think next video I'll be doing PyTorch tensors, and after that we will be doing add a grad. So these two videos will completely explain what is detach, why no grad, and all of those things. Okay, so this is the last video that you have to deal with without knowing these things. So just hold on and let's write it. So what we need to do over here is basically the same thing, output or model, and instead of passing train underscore x, we'll be passing test underscore x. Okay, and then what we will say this is output. Now you can do anything, output, or just say out, or just whatever, whichever variable can be of any name. It's saying over here variable, so it can be any name. Then we will say loss, again even this can be any name, so we will say loss function, and then output, and here output dot squeeze, squeeze, comma, and here we will say test underscore y instead of train underscore y. Now that we have got this one, we will say test underscore loss dot append, and we will say loss dot detach. So already it is detached, right? Doesn't matter, just use it. Dot numpy. If this gives an error, I'll change it. Okay, so I think this is pretty much it. Let's run and see if there are any problems. I hope there are no problems. Output, I think there shouldn't be any problems. Seems like there were none, but we will only know once we are able to print the graphs. So first, for that we will need to import matplotlib. So import matplotlib.pyplot as plt. So let's first run this one, and then what we are going to do is we are going to say plt.plot. We will say train losses. Now sometimes it happens that even after doing everything right, just because the learning rate was too high, most of the cases too high, your loss will not decrease. So it can happen. Here in this case it didn't. However, I think since it's almost going down in a straight line, you have to give some more epochs. I won't be doing it right now, but you can definitely do. But if you see your loss is continuously decreasing without getting that kind of a L kind of a shape, it means you can further reduce the loss. You can see 0.64 to 0.52. Fine, it is coming down, but it's coming down slowly. So one thing that you can do is increase the learning rate, or have this run for more epochs. Since it is not taking a lot of time, I will say run for more epochs. If it was taking a lot of time, I would have told you to increase the learning rate. However, all these things comes through practice. plt.plot. So we saw the train loss. Let's see the test loss. I think similar something. Yeah, same. Which means that both of our losses are decreasing. It means whatever we have written works. Again, to go further, you need to increase this number of epochs, train for one more time. So this is basically it. I think it should be clear. Now you can go and at least you know how to get started. Okay. Obviously, you'll need some more information about PyTorch and other things to be going and implementing other datasets. However, this much is enough for a start. So if you like the video, please subscribe and like and press the like button. Also go to my Fiverr page if you want help in any project or anything related to computer science that you think I can help you. We can have a one-to-one video discussion for some time and hopefully figure that out for you. So thank you very much.